Okay, this is target J of the CAASPP. This is representing and solving equations and inequalities graphically. So let's start with number 1. This one will, oh, look at that. It gives you a calculator. So if x equals n, then y equals 6 is a solution to the equation represented by the graph shown. What is the approximate value of n? So this one it's not super difficult, I believe. All you need to know is y equals 6. Where's our y values? Our y values are right here. And let's look at where 6 is. 6 is right here. So where is the graph touching? So where's the graph at y equals 6? So at y equals 6, which is right here on our graph, let's look for our x equals n. Let's look for x value. So our x value will be, since these are counting by 2's, anything in the half region will be 1. 1. Therefore, they will be the odd numbers. So if it's in between 0 and -2, it should be -1. So B. All right, that's it. Next, if 8b is a solution to the equation represented by the graph below, what is the value of b? So if you are doing this here, it's easier to do a t-chart. So let's start with the first one. We're starting at 0, 4. Next is 4, -8. And the next is 8b. So from here to here, we're adding by 4. Adding by 4. Whoops, 4. Okay, it looks like we have a pattern here. So if we have a pattern there must be a pattern here as well, if it's a line. So here we have 4 minus -8, which is positive 12. So we are, sorry, that was, should be the other way around. So -8 is big. -8 is the next part, so it should be first. -8 minus 4, which is -12. So we are going down by -12. So from here to here, -12. So -8 minus 12 will be -20. So when the value of x is 8, our y value will be -20. So you just use a t-chart here. Next we have here is this graph represents the equation how many ordered pairs x, y for 1 less than x. So from 1 to 9, how many ordered pairs are there? So this is an ordered pair over here, which is around 2, 9. Here's another ordered pair, here's another one, here's another, here's another, here's another, all the way here. Okay, so there's plenty of ordered pairs, so it can't be that exactly 1. So if there's no exactly 1 ordered pairs because it's anything on this line, so it can't be that or this. There's an infinite number amount. So whatever point you choose from 1 to 9, there appears an ordered pair. So there's an infinite number. Next, so this one should be easy, okay? Be careful because this xy right here is irrelevant. What matters is your graph here. So if it says xy, don't look at that. You should be looking at the graph alone. So this here is one solution. So these two ordered pairs, there's only one solution. So there's only exactly one. It's where they intersect. Okay, next. Next we have this. So select one or more intervals. So we are looking at p of x of 13 is 13. So p of x is the same thing as saying f of x, which is y. So we are going to look at our y value here. So when p of x equals 13. So this is going by twos. 4, 6, 8. It actually stops at 10. So you have to keep going. So 12 is here and 14 is here. So it must be here. So if we continued going through this line here, okay, to the best of our abilities, and which regions will y equals 13 reach? So at what x value will it be here? Okay, just by approximate here, I would say around -3 and -4. 3 and let's see here, -3 and -4, and same here, 3 and 4. Since the graph didn't go all the way through. If it didn't go all the way through, then we would just look at let's see here, because the graph of this is x squared minus 1. It's x squared because the middle is here, and we just went down -1. So at 13, so if our y equals 13, it'd be x squared equals square root of 14. Oops, x equals 14, square root of 14, which will be around these numbers, -3, -4, and 3 and 4. So right here. So if anything, you can just approximate it. Same here, p to the third degree. The graph of y equals p of x is shown. So which ones shows you? So here is 2, y equals 2. Let's look at the x values here. So this is around here, -3, -4. The other one will be at around 1, -1 and 0. And over here is 3 and 4. Since it says even integer endpoints, we will not be including the middle one because it's at -1, 0. But let's see if it includes it here. Oh, it does. So then it's -2, 0. But sometimes they're wrong, so. Next one here, which graph represents the equation x squared plus y squared equals 1. So if you go to advanced math next year, you will be dealing with these types of things, such as sine squared theta plus cosine squared theta equals 1. So just like that. So if it's x squared plus y squared equals 1, it will be a circle. It will be a circle with the radius of 1. This right here, the graph of f, enter the solution. So if it's asking for a solution of 2 lines like this, you just look at where they intersect, which is at -4, 4. This is where they intersect. Oh, yeah. So it says enters the x coordinates. So if they're asking for a solution, they're looking for x value. So it should be x equals -4. Next here, select 2 closest approximations for the solutions to the equation f of x minus g of x. So this is the same thing. 0. So if I add g of x here, it's just the same thing as saying f of x equals g of x, meaning it's where they intersect. So we are looking for the x value, which is around before 12. Oops, it's not exactly at 12, it's right before 12. So that's 11.7. Oh, sorry. It's also here at 0. It does say 2 closest approximation. So it's from here, and also they meet here, so don't forget that. Here, how many solutions are there to the equation? So there's one solution here, there's 2 solutions. So there's 2 solutions in total. It's where they intersect. Enter one of the solutions to the equation to the nearest 0.5 in the second response box. So this means which one has the closest 0.5 y value. Actually not y value, x value. So in this one, it is negative 1.5. This here is not even close to a 0.5. This one's about 4.2. So your answer would be this, negative 1.5. Yeah. Either one. Over here, the graphs of y equals f of x and y equals g of x are shown. Indicate whether each statement is true or false. So f of negative 4, this just means y equals negative 4. So at negative 4 for my f, first of all, let me label here. Red will be f, purple will be g. Okay. At f equals negative 4, so my x value of negative 4, which is right here, is less than g of negative 4. So g of negative 4 is up here. Is f less than g? No. At x equals 1, at x equals 1, which is right here. Whoops, sorry. It is right over here. The approximate value of a solution to f of x equals gx. So do they meet here? True. So that means, do they meet at x equals 1? Yes, they do. At x equals 0, do they meet? So f of x equals g of x, do they meet there? No. At x equals negative 7, let's take a 7 right here, do they meet? Yes, they do. That's true. That's false, true, false, true. Oh, wait. F of negative 4 is true. Oh, sorry. Yeah, that's true. Because it is less. F is less than G. Okay, next. Here we did this. We did this in class. Also did this in your quiz. The best part is when they are all graphed correctly already. So since this does not have the line underneath, it will be dotted. So it can't be B or D. Since it's greater, since y is greater, we will be shading up. So it can't be C, so it's A. I won't even check the answer because it's true. The graph shown represents a set of ordered pairs that are solutions to an inequality. Enter the inequality that best represents the solution set shown by the line in the shaded region in the plane. So I should have said this at the beginning, but try this first on your own without me. So pause it and then work on it. So for this one, we look at our y-intercept first. Our y-intercept is +1, so b equals 1. And we look at the slope. So if we're looking here, we go down 1 to the right once. So my slope is -1, -1 and 1. So our m equals -1. And it's shading up, so it's going to be greater than, greater. So y will be greater than, so my m is -1. Don't forget the x, plus 1. That's it. Y is greater, its slope is going down, so it's negative. The slope is always next to the x, and b is 1. So this comes from y equals mx plus b. Oh, sorry, it is solid line. Okay. So first, now let's graph the line x plus y is greater than or equal to 1. All we do is isolate x, so I'm going to subtract x to both sides here. So y greater than or equal to -x plus 1. So my y-intercept is at 1. My slope is -1, 1. So graph that here. It has a line underneath, so it's solid, and it's greater than, so I'm going to shade above. Plot a point representing an ordered pair that is part of the solution set of this inequality that is not on the boundary line. So that means this line right here is our boundary line. So any point here, such as 6, 6, will be a solution to this answer. Anything that's in the shaded area is a solution set. Next, here we go. I want to isolate y here. So what I would do is 3x plus, let me rewrite it. So I would subtract x minus 3x minus 3x. So that's 2y less than equal to 6 minus 3x divided by 2. So if I divide 2 here, I divide it to the whole thing. So that becomes y less than or equal to, and I can separate 6 over 2 minus 3 over 2x. So that will become y less than or equal to 3 minus 3 over 2x. Okay, so this is y less than or equal to -3 over 2x plus 3. So I just rearranged it so that it's y equals mx plus b. Next here, I'm gonna do this one here, minus 4x. Minus 4x. That's -y less than or equal to -4x plus 8. Divide by -1. Remember, divide by a negative number. The sign flips. Y is greater than or equal to 4x minus 8. So I just divide -1 to both here. So let's graph it. So +3 is right here. I go down 3, 3, to 3, to the right 2. So from here, it is a solid line since it's shaded. So this is first equation. Next equation, it starts at -8. I go up 4, 4, and to the right ones. So you do have to be careful of what the number in the graphs are, if in the middle is the odd numbers or not. So in the red, it's telling me that y is less. So I'm going to shade below here. For the other one, it says y is greater than. So I'm going to be shading above. So that means my solution set includes all of these overlapping shade. So any point in this area is a solution that's not on the boundary line. The boundary lines are the lines. Okay. This one's actually wrong, so both of these should be shaded. Sorry, not shaded. Solid lines. So what we would do here is shade. So this is the same thing as this one here. So this top one, the graph is the one that's going downhill. So this one is going this way, and the other one's going this way. Oops. Just to undo. This one is going here. So it's this here. So that's the solution set where they overlap. Next, this was on your quiz. Select the graph that shows the solution set of the system. So y-intercept equals 5. So let's choose one. So y-intercept here is 5. 5. Okay, is there a y-intercept? Here's 5. Yep, they all have the same y-intercept. And now let's do a slope. This goes down to 2 to the right 3 times. So do 1, 2, 1, 2, 3. So this one is correct. This one, let's see, I go down 2, 1, 2, 1, 2, 3. No, so it can't be C or D. So it's either A or B. So in this one here, we know that the first equation is this line right here. We know that these two are dotted because they don't have the line underneath. So it can't be B, it can only be A. All right, last question here. So this is the same equation as over here. Let's see if I can copy it and move it to the other side. Control C it. Okay, good. So these is the same thing here. So let's graph it again. The first one I'm going to use purple. So positive 3, go down 3, 1, 2. So it's going to be going down. Oops. Down over here. Again, they both are solid lines. This is going to be green. So this is less. I'm going to be shading down here. Shading below. Next one is at -8. Gonna go up 4. 1, 2, 3, 4. To the right once. Okay, now I will be shading above. So shading above will be right here. So determine if each ordered pair is part of the solution set. So -4, 4. -4 is a highlighter. -4, +4. Is that a solution set? Yes, it is. How about -4, 0? -4, 0. Let's use red. Negative 4, 0 is right here. Yep, it's a solution. At 0, positive 4. 0, positive 4 here. That's not a solution. 0, negative 4. And at 4, 4 zeros right here. That's not a solution. So when it's asking you to find a determine if it's a solution or not, just look at the graph. Okay, that's it. All right. If you have any questions, let me know. Bye.